Much of the heat and cooling for building structures can come from the ground below the surface with something called a geothermal heat pump. Below the frost line, about 10 feet down, the Earth maintains a nearly constant temperature of 55 degrees Fahrenheit. You can tap into this energy to provide heating in the winter and cooling in the summer. During the winter months, the air is usually cooler than the temperature below the ground. Within a geothermal heat pump, a solution circulates in a loop underground and absorbs the Earth's heat. This heat is brought to the surface and transferred to the heat pump, warming the air to a comfortable temperature. Finally, ducts circulate the air to the various rooms. In the summertime, the system works in reverse. When it's hot outside, the temperature below the surface is cooler than the summer heat. So the fluid in the loop absorbs heat in the building and sends it underground. The ground's lower temperature cools it, and it's circulated back into the building. If you don't have a lot of space, you can go straight down and use a vertical loop system instead of the horizontal loop system. The purpose of a heat pump is to absorb low-grade heat in one place where it is plentiful and to transport, concentrate, and release it in another location where it can be used for space and/or water heat. The ground absorbs low-grade solar energy by means of direct sunlight and rain. This gives the ground a year-round temperature around 55 degrees Fahrenheit. But how can this low-grade heat be used to heat an entire building? A cold water antifreeze mix is pumped through the ground within a series of energy-absorbing pipes known as ground arrays. As heat naturally flows from warmer to cooler places, the antifreeze mix circulating around the array is constantly warmed by the ground's low-grade heat. Having increased in temperature, the antifreeze mixture is fed into a heat exchanger called the evaporator. Within the secondary, sealed side of the evaporator heat exchanger is a refrigerant, which acts as a heat transfer fluid. When the water antifreeze mixture enters the evaporator, the energy absorbed from the ground is transferred into the refrigerant, which begins to heat up and turn into a gas. The refrigerant never physically mixes with the water antifreeze mixture. They are separated like sandwich layers by the plates of the heat exchanger, which permits the heat transfer. This gas is then fed into a compressor. The pressure of the refrigerant gas is increased in the compressor, which makes the gas temperature rise. The hot refrigerant gas then flows into a second heat exchanger called a condenser, which features an identical set of heat transfer plates. The condenser delivers water hot enough to serve a space heating system and, if required, the building's hot water needs. Having transferred its heat, the refrigerant gas reverts to a liquid. This liquid is then passed through an expansion valve at the end of the cycle to reduce its pressure and temperature. Then it's ready to commence the cycle all over again. Low-grade heat stored in the ground is upgraded by the refrigeration process to deliver hot water. For each kilowatt consumed by the heat pump, 4 kilowatts of energy is generated. Effectively, the cost per kilowatt hour is reduced by 75%. Geothermal heat pumps are also clean, safe, and quiet.